Hello, everyone. Welcome back to the Science Data and Analytics stream. I'm looking forward to our next talk that we have lined up, and that is from Samuel Oranyeli. Samuel's going to talk to us about extracting data from Excel with Python, a topic I'm super interested to hear about. There's heaps of data out there in Excel, as I think we all understand. Samuel loves to spend loves speed and anything that can speed up his data analysis and automation. He's a contributor to the projects PyJanitor and PyDataTables libraries. He's a tennis lover and he has a wicked forehand. So, take it away, Samuel.
Thank you. Hi, everyone. Thanks for making all the time for this presentation. We'll just go straight to it. It's about extracting data from Excel using Python. Excel is everywhere. You find it in the business circles, you find it in tech circles as well. There are situations where you need to get data. Probably you're building a pipeline and you need to get one of your file sources is an Excel file, or you're doing data analysis and your data is in an Excel file, or you just need to do some automation. Either way, you have to be familiar with Excel and be able to use it with Python. Python offers a bunch of tools that can help make that processing quite easy. So let's just jump into it. Uh, as I've been introduced earlier on, I love open source projects, I have a blog, and I love tennis a lot. So these are the contents. We'll be dealing with the basics, how to read in your Excel files plainly, and then we'll have a look at the topics that are a little more involved, your pivot tables, Excel tables, and we'll end with small multiples. These are the packages that we will be using in addition to what we have from Python. So we have Pandas. When it comes to tabular data, it's your go-to package. NumPy is what you use. It provides you that faster ability to do numerical transformations. Openpyxl helps with reading Excel files. The beauty of Openpyxl is it allows you to access the cell metadata, and we'll see some examples of that. PyJanitor helps to clean. It's the janitor. It does cleaning and it provides that method chaining ability. We'll see some of its uses as well. So first things first, we import our libraries and we start with the basics. So let's say we want to read from a single sheet. This is how you can read it. You just pass in your file name, pass in the sheet name, or if you're not passing in the sheet name, Pandas will read the very first sheet in that file. If you're reading from multiple sheets, you can do that with Pandas. It will read the sheet names for you in a dictionary. So you can pass in the positions of the sheets or the sheet names. If you want to read in all the sheets, all you just have to do is pass none to the sheet name arguments. And let's say you have your data at locations that are different from, say, A1, or they're not on the first row, or some other location that you're used to. Pandas gives you that ability to read the exact position. So you can use columns argument and say within column C and E, let's say we're trying to read this particular data here from column C and E, skip the first line and read just this number of rows. So Pandas knows how to do that and get you the value you need. Never forget that Pandas in Python is a zero-based index language. So let's continue. If you want to read in, let's take it a bit further. Let's say you want to read in all the Excel files in a folder. That folder has just Excel files. You can use the PyConline library and read in your data. If you can even read it as a dictionary. That way, the name of the sheet becomes the key of your dictionary and then the data frame becomes the values. If, however, your folder is a mixture of files, you can also use the pathlib library and use the rglob to filter just for Excel files only. If you look at this, you can see that we have capital letters in terms of the XLSX, we have the XLS, and we have the small letters. You can just write, this is a filter pattern that gets you what you want, and then you can read it in again as a dictionary. All right, we've gone with the basics. Let's look at things that are a bit more involved. Pivot table with multiple headers. One of this I'd say Excel is the very first place I came across pivot tables. It's used extensively and it helps to visually present data. However, when you want to work with data or do data analysis, there are times when you need to move out from the pivot table format to your tidy format or your long format, where each column represents an information and each row represents a record. So when we look at this pivot table, the very first thing you can notice here is we have this empty space here, which is nice. It gives us that clear formatting, but it's useless when you're doing your data analysis. At the top here, we can tell that this relates to children and adults. Survivors are no and yes. So we can say in the first class, where the sex was male, no child was lost, 5 children were saved, 118 adults did not survive, and 57 adults survived. This is taken from the Titanic data. Now, our job here is to convert this into something tidy, something usable for in case you want to do some data analysis going forward. So if we read it in Pandas, like we did with the other ones, this is what it gives us, which is untidy. It's not helpful to us. We can do a bit better. One of the things that Pandas offers is multi-indexes. So with the multi-index, you can read in multiple columns as your headers and as your row indexes. And this is what it looks like. Just pass in your headers as 01, index as 01, and you can see we have our age and survived, class and sex as indexes and columns. The next thing we need to do is give our indexes relevant names. So we know that the very first column is just for the adult and child, and the next column is for survived. Class and sex is pretty clear, so we don't need to bother about that. The next thing we need to do is get rid of that nan. It's of no help to us. Thankfully, we don't have to do any calculations with the nan, so we can just get rid of it safely. When we drop it, the next thing we need to do is stack it. So if you look at that stack, you can see we now have a sort of clear idea. You can read it from left to right, and you can say second class. When it comes to the female, you have the number of adults that survived were 80, whereas the number that did not survive was 13. It's clear, there are no nulls in between, and you can easily read it from left to right. So we've gotten our tidy data formats to an extent. And all we just have to do is give it a name, just give the numbers column a name, and we're good to go. So from that format on your left in the before, we moved on to pretty clear information on the right. With this on the right, you can do aggregations, you can filter out, you can do a whole lot of data analysis over there. The next step is to look at Excel tables. Excel tables are a feature in Excel and that sounds like tautology, but it's a feature in Excel that allows you to give your specific sections of your data names and features. So if you look at this particular section here, it has a name, age and height columns, it's clear, it has boundaries. If you're in Excel, you could click on the drop down button and you could make some selections. Now, if we're working with Pandas, it is not aware of tables, it just reads in the data verbatim. However, we can use Openpyxl, which is one of the third-party packages to read in the data. What Openpyxl does is allow us to access the tables method in a dictionary. So the first thing you do with Openpyxl is you load the workbook, you access the specific sheets, and if you are curious, you could see that the tables have the keys as the table names, while the values are appended to them. So if we pick into one of the tables or one of the values on the tables, we can see that this is for the Ninja. The name of the table is called Ninja, and this is where your data is located between A1 and C4. So our goal here is to hit every section in the table and pull out the reference detail, which is what this particular code snippet does. And we can read it in as a dictionary, and if we are so inclined, we can combine everything into one table. So what we've got from this section here, we've gotten it into a tidy form, and we can do our data analysis or whatever else we have in mind to do with it. The next one, which I believe lots of folks are pretty familiar with, is conditional formatting. the formatting could have some context or some specific information or meaning. The yellow could mean it's suspect, let's investigate further, while the green could mean approved, go ahead. Either way, that color has some information with it and it needs to be captured. Pandas won't natively capture that detail for you. However, Openpyxl can help you with that. So let's jump into Openpyxl for that. Again, we load the workbook, we read the specific worksheets, and then we iterate through the data. Now we know that the color information is associated with a number, so the trick is to keep the color value next to the cell value. They are hexadecimal digits, so if you look at the results here, we can see that we have your number 65 and then you have lots of zeros here. If they're just all zeros, the color is white. If not, then they are certainly some other color. All right, so we've gotten that from Openpyxl. Now we can read it into a Pandas data frame. This is one of the first features of PyJanitor, row to names. So it promotes the name, age, height from within the data as a header row. The next thing is to set up as an index, because my game plan is to stack our data, age and height, so that I can pull out the numbers away from the colors. We stack it and we can split, give it a name, and we've come to a tidy format. So we're not just reading the data, we captured the cell metadata as well. It might be useful when you're doing your data analysis. Now you can say, Poseidon has a yellow color. I think we should investigate further. Athena has a green color. She's good, even though the age is 1.4, the height is 1.4. But either ways, you've gotten the cell metadata. So we have a before and we have an after. All right, one more. Reading data with embedded comments. Again, if you've dealt with Excel, you probably would have come across this. For some reason, the comments were not put on the side, they were put inside the cell. Pandas can't get you the details, but Openpyxl can. So if you go again, the same workflow. It's a hierarchy. You load the workbook, you access the specific sheets, and herein we use the default dicts because we need to capture them as an array and append them to the key. So we iterate, we look for the cells that have a comment, we put them in the comments dictionary, and we put in all the values into the data dictionary. And so you can see this is our information for the data, and this is our information for the comments. The data for each of them, this is row 1, row 2, row 3, row 4. That is how I capture the data. And we can move further and then combine all the information as one dictionary. Having them in one dictionary now, we can put them into Pandas. If you have a look at this again, you can see we have name, age, height, and none. It would be nice for us to move the name, age, height into the columns names. However, we need to give this particular none something more meaningful. And that is where we come in with the comments. FillNA is a function in Pandas. You limit it to 1, so just the first none is filled. And now we can use the PyJanitor function, row to names. And here we go. So from before, we've now gotten, again, our cell metadata, information in there. So we know Ragnar is a medieval warlord. Well, Netflix helped me with that, I think. And Loki, not so sure about the age. So probably he should be older than 400. But those are information that will help when you're doing your analysis. And finally, we get to the last one. This is what we call small multiples. Some of us might be familiar with this. This is data from Enron, the famous Enron that went belly under. If you look at it, we have a total of 10 tables. If CRG Rocky Mountains, if NWPL Canadian border, what we're interested in here, we're not interested in the charts, we're not interested in the information over here. We just want to pull out all the 10 tables and aggregate them into one. Now, in Excel, you could use your mouse, highlight each of the tables, copy and paste. Fine, easy. What about if you had more than one sheet that was like this, or 10, or say 100? Now that's monotonous. You probably wouldn't want to do that with the mouse and clicks. But with Python, you could pull that off. Let's see how we'll do that in Python and with minimal number of lines. So this is, let's just focus on this. This is what we want to pull out. Now the trick here is to realize that each table has 4 columns. So and each of the columns are linked with a bead and offer characters. So if we can find a way to find where the bead and the offer are located horizontally and vertically, we can then pull out our data from that. Again, each table has roughly about 10 rows. So you have 2 above the bead and 8 lines below the bead. So we can manipulate our extraction. Openpyxl will help us with that. So we create a variable, a rows variable, and a columns variable. Again, load the workbook, read the specific sheets, iterate, and this is where your check comes in. You look for cells that have a bid and offer, and then you can get your rows and your columns. Now these are sets. Luckily, it looks ordered here. Other times, it might not be so ordered. So this is how the data will look like. Remember, we're iterating through the entire spreadsheet, so you will get lots of nones in there, which is fine. We'll get rid of them as we proceed. The next step is to fix our rows. So we create a range, a list comprehension that gives us a range of where we feel the data should be. And this is where we get our ranges 14 to 25, 25 and 36, and on. The same thing goes for the columns. Remember, the columns are 4 per table. So we need to manipulate it such that we can get 4 columns per table. And this is where this iteration comes into play. So we have our rows and our columns. The next thing is to get a cross join between the data, the rows, and the columns, and then use the row and column information. So if I'm iterating, check for each data, jump into the row range. If the row exists in the row range and if the column exists in the column list, add it up to the dictionary, this default dicts. Also, if you notice here, I use a tuple because you cannot, the keys for a dictionary cannot be mutable. So I had to change the type from a list to a tuple. But in summary, this is what it does. So it will give us all the values within that range. Again, if you look at this is range 14 to 25, which is the row and the columns. These are the information we're getting, lots of nones. Oh, it's fine. But at least we're getting our traps in there. Now, we move our data into NumPy. Remember, each table has to have 4 columns, so we use a reshape function in NumPy, and then we can vstack, so we'll combine everything into one. And then when we're done, we read it into Pandas. We use another function from PyJanitor, which is remove empty, which simply removes all completely empty rows and columns. And then we can add a prefix just to make it easier for us to work with. So this is how your NumPy data looks like within NumPy. Lots of nons, but look at that. All 4 rows. And then we hit the parts that we are keen about. You can see how we're getting some progress here. We read the data into Pandas. We've gotten rid of the empty cells or the completely empty rows and columns. And this is what we're left with. It still needs a bit more cleaning. And we can run some functions on that. You use your assign, your field direction, your query. Basically, you clean it up to get something way better, and which turns out to be this. So from that format that we had at the outset, we've gotten to something clean, about 70 rows, but in a form that we can work with. And look at the number of lines, roughly 30 lines of code that is reusable. I mean, is Python powerful? Is it not fantastic? So this is your before, and this is your after. Easy. Python does a lot for you. Again, I say it, Python is powerful. As long as you understand your data, as long as you know what you're working with, you're fine. These are the resources I use. I read the documentation of Pandas. This colleague, well, I'd say is a great person in the R community, Duncan Gammonsway. He has a book, an ebook called Spreadsheet Merging Strategies. Very lovely, lots to learn from there. The Titanic data was from the tidyxl repo and R package. Enron is from the unpivotal repo. It's an R package as well. And also my experiences with spreadsheets. I worked at two international banks and I dealt with a lot of spreadsheets over that period. Hair-raising spreadsheets, but they were fun, they were interesting, and they were enlightening as well. The code and slides are over there, and this brings me to the end of my presentation. Questions, comments, feedbacks, but as I said, Python is powerful and it offers you a lot, so go and conquer.
Cool. Thank you so much for that, Samuel. That was great. There were actually a few people asking about the code, whether that was up on GitHub. So there's the link there. So that's awesome. We've got time for a couple of questions. One is from Bosco. Are there ways to import Excel formulas into Python?
Yeah, there is a way. Openpyxl can offer you that, but recently I listened to a podcast and there is a particular package that allows you to read in the exact formulas. I think it's an improvement on Openpyxl. But to answer your question succinctly, Openpyxl can help you with that, but just check out, there is a better package that does that as well.
Yeah, cool. I think maybe we can have we can share links to some of those libraries in the chat.
Sure.
There was another question that I thought was interesting was what do you do when you get over 1 million rows in Excel?
The 1 million rows question. Now there are two tricks to it. One, you could read it in Python. You could have to deal with the speed or the memories of Pandas. Or if you are so inclined, really, Excel has had some improvements. So they have a feature in Excel called Power Query, where you can read in your data into that. There is no limitation when it comes to the number of rows that can be read into it. However, when you're exporting your data back to the Excel spreadsheets, it cannot be more than 1 million rows. So again, you can do it within Excel with Power Query, or if you're a Python fan like I am, just read it into Pandas or work with Openpyxl, and you can manage your memory limitations. I mean, if you find a way to deal with your generator expressions or your iterations, you'll be fine.
Yeah, great. I'm quickly going to squeeze in one more question, again from Bosco. Is there an easy way to refer to cells and ranges of cells? I think Bosco's frustration is having to write his own cell naming functions.
In Openpyxl, you can access named ranges. So if your ranges have names, you can do this. And if you're sure, let me just summarize that. Openpyxl is a wonderful tool. If you know how to play with it, it will solve a whole lot of your problems when it comes to accessing data. XLRD is also a pretty wonderful tool. I just feel more comfortable with Openpyxl.
Cool, awesome. Well, thank you so much for that, Samuel. That was amazing. I just have a couple of quick conference announcements, and that is that there are a few interesting things happening on Sunday. We have the Birds of a Feather sessions. We have mentored sprints, always a good opportunity to get a chance to get stuck into some open source contribution with people, the maintainers of the packages. And there's even been some unofficial rumors that there are going to be lightning talks. So stay tuned to things. Check the announcements page in Venulus. And yeah, please keep all the discussions happening in Venulus. Samuel, do you have time to hang out in Venulus to chat for a little bit?
Oh, definitely.
Awesome, cool. So yeah, let's keep the conversation going, and we'll hope to see you for the next session in about 10 minutes, and that's actually going to be on Dask image, so all about processing, distributed processing of images. Looking forward to that. Catch you all in a bit.